Hello friends, very good morning. Myself Dr. M.H. Chennaiya, and in today's video we are going to work out a problem on the section of a hexagonal pyramid which is resting on its base on HP, and it is being cut by a section plane such that the true shape of the section is going to be a regular hexagon of a given side. Let's see what is the question we have for today's video. A hexagonal pyramid having side of base 30 mm and height 60 mm resting on its base on HP is cut by a section plane such that the true shape, TS means true shape of the section, is a regular hexagon. Is a regular hexagon of side 20 mm. Draw its projections and obtain. He has given a lot of questions there. Friends, now we should know the simple concept that whenever any of these pyramids or any of the cones are resting on its base and are cut by a section plane parallel to the base or perpendicular to the axis, the true shape of the section you obtain in the top view is going to be a figure similar to that of the base. That is to say, if you have a hexagonal pyramid, whenever you cut this parallel to this base, you get hexagon as the true shape. If it is a pentagon, when it is cut parallel to the base, that is to say when the section plane is horizontal, you are going to get a regular pentagon depending on the position of the section plane. Closer to O, smaller will be the size. Closer to the base, you will have bigger figures which are exactly similar to the base. So, based on this concept, we can work out this problem. It is said in the question that the regular pyramid, that is hexagonal pyramid, having side 30 and height 60, is resting on HP. It is cut by a section plane. So they have not specified anything about the section plane. So we have to remember this concept. It is possible to get the regular hexagon or square, whatever it may be, depending on the solid. It is possible only when it is being cut by a horizontal section plane. Friends, here the hexagon you are going to get in the top view is going to have a side of 20 mm. Friends, this is 30. This is also 30. So we can have a line drawn here at a distance of how much? 20 mm. That is 10 on either side. And friends, you project the line from there. So from here, if you project the line, this line will touch these slant edges at a height, and all these six slant edges of the pyramid will be cut by the section plane SS at the same height. That is to say, this second point, third, fourth, fifth. So all this you are going to get on the same line. And friends, now this figure, whatever you're going to get here, is going to have a side. How to get it? You produce it downward, the same line. Friends, remember this is 10 and this is also 10. 10 plus 10 is 20. Write a vertical line from there, a vertical line from here. Friends, you get 2 points on these two slant edges. In the top, you keep drawing lines parallel to that second, and then you are going to have third, fourth, fifth, and sixth. Friends, you are going to have a regular hexagon which will be having a side 20 mm. And here, friends, before we hatch it, let us project all these points. So as A, B, C, this is D, E, F. And here, friends, this point will be A dash, this is D dash, this is E and C dash, E dash, this is B and F, B dash, F dash. And friend, this is O dash and O1 dash is here. This is O comma O1. Friends, after the section of the solid is being cut by the horizontal section plane, we have to darken or show by dark line the portion that is remaining after the object is being cut. So it's better we can avoid this line also so that it looks better. So friends, this is how the base looks here, and these slant edges are to be shown by dark lines. So friends, this is our section plane SS, and this figure will give you the front view of the hexagonal pyramid. And here we have got the 6 points here. Let me mark them as 1 on OA, 2 on OB, this is 3, 4 on OD, 5 on OE, and 6 on OF. Friends, these 6 points are joined by straight lines, and we have to have it has section at lines drawn at an angle of 45 degrees to the horizontal. So friends, this portion you can see here, the complete base of the solid is intact. So I will show by a dark line. All the edges by dark lines are visible lines. And this is how the solid looks, and all these portions are retained. So I have to show this by a dark line, this remaining part all by dark lines or visible line. Friends, this figure in the top view will represent the sectional top view. STV means sectional top view. This is the front view, and we've been asked to draw its true shape. Friends, whenever any solid is cut by a horizontal section plane perpendicular to VP, whatever the hatched portion or sectioned portion you get in the top view is going to represent the true shape of the section. The complete figure is called the sectional top view, and the hatched area here, figure number 1, 2, 3, 4, 5, 6, represents the true shape of the section. And this true shape as given in the problem is a regular hexagon of side 20 mm. This is 20, 20, all sides are 20, and the section plane is horizontal. What is they have asked in question, friends? They have asked us to obtain nature of section plane. So what is the answer for nature of section plane? It's very obvious from this figure that the section plane is horizontal, or the section plane is parallel to HP and perpendicular to VP. That's the answer for this part. Location of the section plane, that is to say, with reference to some reference point, say from XY, how far is that horizontal section plane? I can simply write a line here and say this is the location, or it is the distance of section plane from HP. Friends, you can measure this using a square scale, and that will give you the answer for this part. STV and FV. F is the front view, and STV is the sectional top view we have drawn here. And friends, development of the lateral surface. Add the development of the lateral surface. Friends, what is to be done now? We have completed 3 parts of the question, and taking this lower portion of the solid, we have to draw what is called the development of the lateral surface of the pyramid. So suppose if I call this part as P, we need to draw the development of the portion P that is below the section plane, whatever you have got. Friends, you know very well, for all the development purposes, we have to make use of true lengths of all the edges, whether it is a slant edge or a base edge or a longer edge, we have to make use of the true length. And friends, if you see here in the top view, we have this slant edge OD parallel to VP, and hence this line O dash D dash will give you true length, and this true length is the same for all the six slant edges, namely OA, OB, OC, OD, etc. Now, friends, taking that true length, I am going to draw a line here of length is equal to TL, and I just now, friends, taking O as center and this true length, that is O dash D dash as radius, I am going to draw an arc, here. And friends, on this arc, I am going to step off six sides AB, BC, CD, etc., each having 30 millimeter. So starting from here, say this is 30, second 30, third 4, say 5, and this is 6. And we will join this together. And I am also going to join all these points by straight line. They will be representing the slant edges of the pyramid. Now, friends, if you observe the base of the solid, this base is intact because section plane is not touching the base. So what I can do, I can just draw all these, join all these by straight line. Say we are marking A, B, C, D. We can start from A or B or whatever it may be. C, D, E, F and A. And all these base edges for any pyramid are straight edges and you have to join by straight line. So friends, I am going to join these A to B visible line, B to C, C to D, D to E, E to B, E to F, and then A to F. So all these I am going to join by straight line, friends. Now, after this, all these are having measurement 30 mm, 30, 30, 30, etc. And this is the true length we have got, and this true length you should remember is O dash D dash or O dash A dash, because both OA and OD are parallel to XY in the top view. Now friends, if you observe this figure 1, 2, 3, 4, etc., this is 1 on OA, 2 on OB, 3 on OC, 4 on OD, then again 5 here, and this is 6, 2 and 6. This is how we are going to have. And if you observe this front view, friends, you can see all these slant edges, all the 6 slant edges are cut by the section plane at the same height. So, in cases of all pyramids, if it is cut by a section plane parallel to the base, that is by a horizontal section plane, you can obtain the true length of one of them and simply draw an arc. For example, here, this is the true length. All these points lie on the same line, so you can take the distance O dash to this distance as the radius and draw an arc here. Suppose a thin arc. And friends, all these points here are to be joined by straight line, straight line, straight line, straight line, straight line, and straight line. And the portion below that is to be retained. So this I show by full line, full line, full line, line from here, line, line. So I joined all these by full lines. And friends, if you observe this figure, you will also notice that since the section plane is horizontal, Whatever these lengths you have got here are all parallel. The section plane is parallel to the base, and all these edges, for example, this edge is parallel to this edge is parallel to this is parallel to this edge is parallel to this, and so on. And friends, here this will give you the development of P, the lateral surface of the lower part of the pyramid when it is cut by a horizontal section plane. Friends, I hope the presentation was interesting, and I am very sure and very confident that all of you would have followed the instructions given to solve this problem on the section of hexagonal pyramid. And you should also observe here, friends, this is one of the very important questions wherein I have covered two problems in the same video. One is on the section of the hexagonal pyramid, and the other is on the development. So by studying this problem, you will know the procedure how to obtain the development and section of a pyramid which is cut by horizontal section plane. And once you know this, you can work out any of these problems or any of on any type of pyramid, including the cone. In the cone, you are going to have a circular end, and this is going to be circular again. We are going to sharpen only the last edges. Now, if you want to mark this also, you can mark here as 1, 2, 3. This is 4, 5, and this is 1. I told you 1, 2 parallel to AB, 2, 3 parallel to BC, and so on. Friends, please go through the complete video without skipping anything in between. And if you like this video, do share with your friends without fear. Thank you for watching my YouTube video.